So we're at the top of a Indian bean tree in Buxted, pretty big example of that species. I've only ever seen one of this site before. That was in South East London a few years ago. We were called out about 2 or 3 weeks ago in response to some storm damage. You can have a look at that just on the left there. The central section was broken out in two main parts, and that was actually lodged in the piece that we're sat up in at the moment. So we took out the storm damage and assessed the tree in response to that call out, and we decided that the best treatment would be to reduce end weight so that we can try and minimise the chance of future breakout, and also we thought about putting in a bracing system, so a loose bracing or boa system, to provide some damping between the two main sections. So if we have a look down, we can see the large crack on this main section. As we move the tree, we can see that that's just very slightly opening and closing. So what we want to try and do is brace this section to the limb that goes off on the opposite direction. So we're going to use a 2-ton system, boa, and we'll get to that in a minute. And then maybe we're going to put in another connection from the broken central section out to the sort of 5 or 6 inch diameter limb out on my right. And again, if you can have a look, that's got a large crack and probably a large cavity. Okay, so we made an initial plan of bracing position, and what we're aiming for normally would be around about 2/3 up the tree, getting a suitable fork to stop the system from slipping down. In this case I'm going a bit lower than I would normally, about this sort of position, and then across out to my right there on that slightly ascending branch. So the we've got comprises the rope, which is a hollow braid. It can open and we can press, and that's how we can insert the various other components into the rope. And then when it's under tension, obviously that is closing, a bit like a Chinese finger trap, Chinese finger trick. So that's how we can actually splice the rope back in on itself. We can form the eye, and also we can insert the other parts of the system. So if we just have a look at those, we've got a wide band which is designed to spread the load where the in contact with the tree, so sort of reducing the pressure there, reducing the effect on the bark. So that gets inserted into this rope. Then we've got an expanding, a shock absorbing system rather, which is designed to give sort of a smooth damping effect. So in effect, I suppose, like a spring in the system. And then we've got another sleeving system, which also provides extra protection for the bark. We can just cut some scissors or a sharp knife, and when we get those frayed ends, we can use some specially supplied tape to form a nice, neat and easily spliceable end. So we can open up this braid, and we can just insert through the boa rather, and we can just pop out again. And then when we pull, it's going to form a nice tight splice. I choose my position, boa around the stem, and get an approximate position to insert the expanding strip or band. bands can be trimmed and adjusted to suit the diameter class that you want. Looks like they've got a universal size now for expanding bands and also shock absorbing elements in this system. It used to be different diameter, different width for the 2 and the 4-ton system. Now it seems that they got a universal size, one size fits all. That's now in the complete wrong position. I need to move it up. Anyway, that gives you an idea of the load spreading properties of this system. So it's just spreading that rope out to minimise the surface load. A bit of fine tuning on positioning that band and getting enough tail in order to form the splice. So we don't want to form a splice too tight around the stem. We want to have relatively low entry angles there. We need a reasonable quantity of rope buried, say about a foot or so, and then we also need some material coming out the tail, so that allows for future adjustment. And also, you can adjust it when you're on the go. So if you make an error, you've still got a bit of room for manoeuvre, and then you can also accommodate future growth as well by making adjustments in response to any inspection regime that you set up. So at this stage, I'm reasonably happy with the boa setup, the actual rope setup, and I just need to use some of this sleeving. I just need to measure that. Now we've got sleeving over the expanding band. Position that band relatively central and the sleeving. And then choose the insertion point, splice, open up the rope, insert it. But that'll do for the moment. We've got a reasonable amount of rope buried there to form the splice. Just a bit of fine tuning at the end to adjust that band in position. Now we can move to form the other splice at the far end. Correct positioning for the splice is that the distance between this central part here where you form the splice and the stem is equivalent to the diameter divided by 2. We then bury the line for approximately 30 centimetres, and then it pops out into a loop, an adjustment loop, and then is reburied for a minimum of 15 centimetres. And we've also got a couple of coloured discs here where we can use these to have a very immediate visual check on the age of the system, the installation date, so that we can keep an eye on that in terms of overall lifespan. So this one here, blue, it's got an arrow to 2012, if you can just spot that there. There we go. So when we get the other connection in, we can do a bit of fine tuning just to tidy up that whole system. So I just wanted to give a bit of a feel for the size of section that's previously failed on this tree. So we just have a look down here, this section of my feet here, pretty substantial limb broken off. That's got to be a few years ago if we look at the reaction around the edge. So just choosing the position, I've got a couple of options. I could drop into this fork here, but I think I prefer to go out this smaller one here. I think it will avoid loading up this section here, which is potentially weak. If we look at here, we can see where this would definitely be likely or have a tendency to split apart. So we're going to avoid that. Go to the lower one. So I'm going to go around here. For my splice, 30 centimetres. Small loop, another 15, and a little bit of spare, and we can make a cut. This tape comes supplied as part of the kit. I'm going to pop that around the end just to make the splicing process a bit smoother. It does help if you can just capture those fibres that poke out on the end, and they do tend to get caught. There's quite a bit of resistance. Okay, so we're back into expanding band. Choose the approximate position for that. Insertion point. Yep. So we've just popped in the second connection, and we've introduced a little bit of slack into the system because we need to have room to insert the shock absorbing element into the approximate centre. So we won't be able to do that with tension. We won't be able to open up that braid and get it in there. So we need a little bit of scope and a bit of slack in order to do that. And once we've got this inserted, then we can fine tune the whole system. It's worth saying it's not designed to be inserted and maintained super tight like a steel cabling system. It's designed to be able to allow the tree to move relatively naturally, just limiting the extent to which the tree can move. The adaptive growth can still occur because the tree is still being influenced and moved by the wind, so the tree can respond to some extent. Whereas with a cabling system, if it's very much rigidly held together, then there's no scope for that adaptive growth to take place. Yeah, so we just open up that braid, and this is a lot easier to insert because it's much smoother. You can see even with that slack that we've left in the system, it's still quite tricky to insert. So if we just open that out for a moment, it becomes a lot easier. Okay. So how's that working? When the rope is stretched, the tree moves, then the braid is tightening around the rubber. Okay, so we've got that first connection all finally adjusted, tensioned and set up, ready to go. Just a final thought really is worth mentioning that whilst we've got the shock absorbing element into the centre of this connection, we want this to be allowing a relatively natural movement, but just less extensive than normal. We could provide a fail-to-safe system. So if we had a limb where we felt that there was a reasonably high chance of it failing, then we could actually use a system like this, but minus the shock absorbing element, just to provide, if you like, a safety net, so that if there is a failure, then it's not going to reach a target lower down. Obviously, a high value target, I wouldn't think that approach would be appropriate, but maybe for lower value targets, perhaps certainly not involving people, it might make sense to retain high amenity value limb using that system.